Hello, Jeff. Good to see you again. How you going?
Doing good. Head in the data, head in the clouds, and happy to be here.
Feet on the ground, I hope.
Feet on the ground, I think.
Excellent. At least somebody does. Yes, we are here today to talk about Hurricane Helene, a very serious topic. Our hearts definitely go out to the families involved that have been touched by this horrible tragedy, and especially to those who've lost family members. Thinking about you guys. And there's a whole flood of muddy waters out there in more ways than one, in an informational way as well. So we're here to try to sort out some of that stuff for ourselves as well. But yes, a lot of misinformation. So let's have a look at some of the facts and see what we can come up with. I'll show you what was being presented to us collectively. Particularly in like places like YouTube and social media, etc. Now, every single one of these screenshots that I've taken here is it screams Category 4 hurricane, right? Whether it's in their title or on screen. There was a lot of language used too, language such as catastrophic. I mean, yes, it was catastrophic, life-threatening, unsurvivable, monster, unprecedented, all those things that we've sort of come to get to know. They're going to have to outdo themselves every time with new words. But there was a lot of hype built up around it, in a way rightly so. However, there was a lot of misleading hype as well. That seems to be the norm these days in our climate crisis days. Every time there's a storm, everyone's running around with their arms in the air screaming HARP or CERN or something. And there is a lot of misinformation around, so we're going to try to sort all that sort of stuff out. This guy here should be wearing a bow tie, in my opinion. But as you know, they're all actors. They're all there to stir the hype. And even though there was a lot of tragedy that came out of this, there was also a lot of build-up and fear that may not have been entirely necessary. So we're here to try to sort some of that stuff out and teach a few people a few things about how to possibly look at some of the weather themselves and not have to rely on these hyperbolic propaganda clowns. So I'll let you take it from here, Jeff. Can you set a few things straight for us, please?
Yes, I shall do my best on that. I've been looking at the data for about, probably 24 hours in the last 3 days. Yesterday was a 14-hour day looking at data, and I'm seeing numbers. That's not mixed up anymore. I have a pretty good idea exactly how it happened, and I'm going to show you the path, why the flooding happened, which is the biggest thing. I'm going to show you that the winds were not as advertised from minute one when it came ashore. It was not Cat 4. I have not one wind that says even Cat 1 from the observations. And that's from professional weather observers and the instruments that they use if it's an automated station. So that wind forecast, the strength is based on what the wind speed is. And that scared a lot of people because they're thinking Cat 4 and it's not Cat 1. It was tropical storm strength the minute it hit land. Right. And the flooding, I'm going to go over why that happened. And the word is orographic. In other words, topography. Asheville, North Carolina was due to exactly that. And I'm going to show why it tracked like it did, which was a big hook to the left. So there's a whole bunch of stuff that I'm going to try to cover here with data from the observation points as the basis for it all.
Okay, awesome. Now, I just want to point out that if anybody has any questions about the weather, whether it be this event or others, you can send those questions if you like. To weather@stellarq.com.au. Don't forget the .au, and we'll be happy to address those in one way or another. So let's get stuck into this. What would you like to show us first, Jeff?
We'll change my screen over to that right now. There we go. I have it.
Alrighty. Take it away.
Okay, so this is an app called Zoom Earth, and it shows the track. And it's really cool how this thing works. It shows you from down when it was near Cuba. There's Cuba right there. It shows it formed up right here as a potential tropical cyclone, and then it turned into a tropical storm with winds of 65, and as it progressed up, 85, 90, turns into the red zone major hurricane. And they said it was a Cat 4 just before it hit, but I don't have any evidence of that. So after that, I have a little measurement device right there that shows that it was 496 miles from the time the eye hit that location right there, which is on the coast of Florida and like what they call the Big Bend, up to leaving Tennessee into Kentucky. It covered that in 12 hours, 500 miles.
Okay.
And by the time it gets up to the end, it is absorbed into another area of weather, which I'm going to show you on the charts. So that gives you the big picture of what happened. I'm going to also now go to so there are two scales. I'll point out first, the Western Pacific goes by this, but this is NOS. Typhoons are what they call them over there.
Cool.
This is not what applies to this storm. I just want to show you that there is another scale. So you got tropical depressions, tropical storm, severe tropical storm, typhoon. This is for the Western Pacific. So I just want to make you aware that it's called RSMC Tokyo's Tropical Cyclone Intensity Scale. We use a different one over here in this part of the world. So I'm going to go to that. Okay, so meters per second, knots, miles per hour, kilometers per hour, whichever your chosen category is. You have tropical depression, TD, tropical storm, TS, category 1 through 5. And each of these has increasing wind speeds. So they were saying this is Cat 4. In miles per hour, they were calling for 140. That's 130 to 156 range. So that's what we were expecting. I'm going to show you a whole bunch of data that says we didn't get what they were expecting. So
yes, because as I just showed you on that PDF, everybody was going with Cat 4, and I'm just wondering where that came from. So I guess you're about to show us.
Well, I can show you where that came from. I'm going to jump out of sequence here. I'm going to jump down to flight radar first because I need to show you some flights. Actually, I don't want to do that. I want to show you.
I don't want to upset your flow, man.
No, it's okay. It's segue into that. The timing is right to do that. So I'm going to show you the flights that check the strength of this. So this is Flight Radar 24, and it shows this flight right here that took off from Biloxi, Mississippi. And if I scroll down a little bit and increase the size of that, up there you can see the flight path, and everything's color-coded. And if I move that little cursor, it tells you where they are and what their altitude is at that time. So they take off about 3:27 UTC time, this is the day before the hurricane. It was down by Cuba at that time.
Okay.
So you can see that this guy goes in, he takes off, and he goes up to an altitude of about 30,000 feet. And he drops down in the middle of the hurricane, which is down in that area, down by Cuba and Yucatan Peninsula. And he penetrates it at 10,000 feet, 5,000 feet in this case. And he flies through it at 5,000 feet. Then he pops back up and flies back. That's the first flight. So this was early the previous morning, I think it was. As soon as he got back,
sorry, can you just tell me what exactly are they doing here?
These are the guys that fly through the hurricane with the instruments. They call that the Lockheed Martin WC-130J Weatherbird.
Okay.
And they have several of them. So that flight gets back to its destination or its home port, and then a second one comes out.
Sorry, I just need to ask again. So are they're flying into the hurricane area to measure the wind speed and all that kind of thing?
Yes.
The actual wind speed, not just their projections.
Correct. They have all the fancy instruments. I've seen videos on it that shows the guys all sitting there buckled up and penetrating that storm multiple times. So you can see that it's right off the tip of the Yucatan Peninsula right here because they're just going through it multiple times. They're like doing a star pattern almost.
Yeah.
And this time, this little cursor right here, when you move this guy, it shows you their height, their altitude, 10,000 feet above the water. That's where they're doing all their measurements. This is not surface winds. I don't have access to that data. I just have access to the path. So that was the second flight. That was Teal 72. The previous one was called Teal 71. That's what they nicknamed that flight.
Okay.
And then you have another one. As it's getting closer, they're doing the same thing. Out of Biloxi, and same thing. This one goes in also, does 10,000 feet through that whole duration, which was from 2312 UTC. They dropped down from their flight level, which was, they came out at 17,000. They dropped down to 10,000. And for the next, from 2314 out to 02, almost 0300, they were 4 hours going through that thing to get a beat on it. So that's where they were getting their numbers.
Certainly good danger money.
Yeah, it'd be quite the roller coaster ride, but
sure would.
That aircraft
Tom Cruise, eat your heart out.
And it even gives the speeds of the aircraft. So it's doing 278 knots. That yellow line shows the speed of the aircraft at every moment, 300 knots. And they're dealing with 100-knot winds. Might have been a side wind as they're going through a wall or something like that. I don't think it would be all that fun.
No.
There was also one more aircraft that did not appear to be going actually into it. And this is a
chicken.
It's a chicken. It's a Gulfstream 2A, and I don't know their purpose. I never actually got to the point of looking at it, but you could see from the blow-ups, they were around it. So like if I back up to right here, they took off from way up in the northeast, somewhere Virginia looks like, got to the coast right here. So they're at full height, full altitude, and they dropped. Their altitude drops down right there.
Is it possible to zoom in a little bit on that so that we can see the little plane a little bit better without mucking you up? Because that's pretty damn cool. Just, even if it's just briefly, just so we can see, because that little plane, it's pretty cool. So when you're moving the little dial,
yes,
that's moving the plane. So you're showing exactly the flight path.
Exactly.
Yep. Okay.
I don't know if I can. Yeah, I can still do that. Here we go.
That's all right. I just wanted to show the folks. Yep.
You can say they were not in the hurricane at any point. They were. Right. By the time it got to this point, it was already northeast of them in the bay, in the Gulf.
So are you saying that this is a measurement plane, or?
I don't know what their reason is, but I don't think it's like they're not flying into the storm. Not sure their purpose. So maybe I should have researched that before I even showed this, but that was the only other military aircraft I could find that was anywhere near that storm.
Oh, it's military. Okay, that's why you're showing this. Okay, got it. So would it be valid to say that, they're measuring the outer areas?
Okay. It is NASA. So scientists.
Never a straight answer. Okay.
So it's not technically military, but it is kind of.
Kind of, sort of, same black op. So, okay. So they're measuring the outer area possibly. But anyway, it's certainly not, well, let's just say it straight out. It's not a cloud seeding type path, obviously, by the looks of it.
Correct.
And I did want to sort of say, because showing the flight path before of those other two planes, the measurement, that was an interesting kind of looking flight path. And I could sort of hear in my head there might be a couple of people who go, oh, that's a strange flight path. What are they doing? It's like, well, they're
Exactly.
measuring. Okay, so let's just take note of that. This is the sort of thing you'll see when there's measuring type apparatus happening up there.
So, yeah, very durable plane going in and out of a hurricane. That's a job I wouldn't want, but they do it, and that's where they get their numbers.
God bless them.
So that's your starting point. Technically, they should have been seeing 140 knots, but they are at 10,000 feet.
Mm-hmm.
That's not what we experience down here. So I don't know how they translate that number to the surface wind. I'm not quite sure how that happens.
All right.
So going back to this thing, it shows that track again. And if it wasn't obscured by clouds, you could see exactly where that is. I'm going to go to this app showing it instead. This is one of my favorite apps. Anybody in the Climate Viewer group will know that I use this whenever I reference a lot of stuff. So it started in Big Bend of what they call Florida.
This is Ventusky or Ventusky. I'm not sure exactly how to say it.
Yeah.
But
So
it's an excellent app, and we've shown this many times in the past, and we will be using it again. So highly recommend Ventusky or Ventusky. Depending what part of the country you come from.
Why this is important is I'm going to be showing winds on the cities along this path, the measured winds from the professional observers. I'm going to be toggling between this screen, the RAM slider satellite data, and the actual observations to show what we actually was experienced. After we go through the winds and establish that these locations were exactly as the app showed they were, then we're going to go into the rain data and show you why that happened. And as we call synoptically, it's a fancy word that the forecasters use for what's the big picture, looking from way, way up. And I actually think I'm going to deviate to that right now. Why did this thing actually curve to that weird question mark shape?
Yes, because naturally we have a lot of people out there going, see, it's not natural. It's not the way it should work. It's like, okay, well, tell us.
You would think that it's not natural. It doesn't seem natural.
Yeah.
So
it's fairly valid. I'm not trying to make fun of people. I was one of those people not that long ago that would, be calling HARP or whatever. It's like, it's been really good to be educated and learn a bit more about what's actually going on, because it takes a lot of fear out of the equation, and it also helps you understand what's actually happening. And yeah, not as easy to fool when you're educated.
And on top of that, I don't know about all of you, but I go back to 11th grade, or was it 10th grade? A long time ago. I'm old, and I'm not going to tell you how old, but I'm an old guy.
Ancient.
Lots of experience, which means I've screwed up a lot of times. So, Earth and space class, I loved it. That was part of the reason why I became a meteorologist. I was trying to go for oceanography first and didn't like college, so ended up in the Navy doing the weather forecasting, observing and forecasting. So nobody has the training in weather. I mean, if you loved Earth and space, maybe you've sought it out, but nobody knows anything about weather. You're not taught this stuff in school very well. So I just want to go now and show you that this is what you call
true. It's very true. I don't remember ever going over weather at school.
Who knew what clouds were? The cumulus is a cumulus, the cumulonimbus is the thunderhead, all that stuff. I mean, we covered that here to help people understand the weather. But so I want to get back to this now. The synoptic situation shows these are the 500 millibar winds. That's a pressure level about 18,000 feet off the ground. So right here, there's what you call a trough of low pressure and a cold front. And if I click the satellite,
that's the blue spiky line we're looking at there.
Where you have the blue spiky line, you have a band of clouds, and that cloud area is raining. And the same thing over here. You have a large frontal system on the eastern seaboard, eastern third of the country, and it is moving out to the east. Both of these are moving to the east. So I'm just going to click a day forward at a time. So you could see that this has moved farther over. And when you look at the wind speeds,
We're currently on the 24th of September.
correct. So this is a couple days before it happened. So I'm going to click back to 500. I want to show you that first. So this
Okay,
right
this is the
here
wind speed.
is the
Wind speed
trough,
chart.
right?
Yep.
So this is cold air coming out of Canada, and it's pushing to the east, and the cold air is right behind that line where it touches the ground. So
Okay.
as I click my way through there, you're going to see that that trough keeps on going farther to the south.
This
That
goes
cold
hour by
air.
hour. Is that
Yep.
right?
But these are every 3 hours steps
3
right
hour
here.
intervals. Okay.
So that right there, if you look at the very top, you can see the 0900. That's the uniform time zone, UTC,
Yep. Yep.
/ Zulu. And if I click it again, it's going to be 1200. So yes, these are 3 hour increments.
Okay, we're on the 25th of September now.
So the jet stream is diving out of the north. If I look at the temperature of that, I'm going to show you that there's cold air. If you look at the scale in the lower right, that is, this hand doesn't do me good. It's like -20. You could see on the scale over here to the lower right.
Oh, okay. Yes, the dark purple is -20. Yep.
And right here, the
Magenta.
blue would be around 0. I can't see it around the hand, but -5. So it's a lot colder than the air elsewhere. That cold air pool is what's driving that cold front. So
Okay.
go back to wind speed again, and you're going to see right here that as I click forward 3 hours again, what happens is that becomes what you call a cut-off low. And as this thing progresses in time, the jet stream, which is the red, goes away from that. It's farther to the north. This right here, that is just out there separated from the main flow right now. It's called a cutoff low because it is cut off from the jet stream, and it's just meandering there.
It's sort of doing its own thing.
It's wandering. It's on walkabout. I don't know what you want to call it, but
Okay.
it's just there.
Party of one. Yep.
Back up a little bit more right here. So check out where HELENE is, first of all. HELENE.
Yeah.
I was calling her
It's got an E
Helen
on
at
the end.
first.
It's got an E on the end, mate.
So it's down by Cuba, and then it's coming up, and I want to show you where. I'll jump to the satellite real quick here, and you can see it looks like a huge mass of clouds, but it's a blend of the cold frontal stuff and what's starting to stream up from HELENE. So that's not all either of the two. It's a combination of the two. And you can see as the hurricane continues to move north, now it's into nighttime. So this thing does show night, and it's at 0300 right there, 0300 UTC, it makes landfall. And I'm going to show you the radar at that time. So there's already rain up there from the cold front that's exiting very slowly, but it's exiting. Now you have a blend of these two. So at that moment, when I go back to wind speed on the surface, it's showing, I'm going to zoom in. It's showing, I really dislike this hand thing. See how it hides the numbers?
Yeah, I know.
So I was looking at the speeds of the winds, and it's in the 80s at that point. That doesn't match with 140. I'm sorry, it doesn't match. But this is an application, right? This is Ventusky, the application. There's nothing higher than 86 miles per hour. So I'm going to show you. I have all the data for each station. So I'm first picking this place right here, which is called Crystal River. And if I go to the Crystal River data, okay, so this shows the station name. The next column is the time in UTC, Zulu 270235, for instance, right there.
So that's the 27th of September at 2:35 a.m. Zulu, yeah?
Which is when it made landfall. So back in time, when it was farther south, it would have been near 2315. And you can see, just go through all these numbers right here. This is the wind direction. I have the highlighted 14025 G35 KT. That means
What does that mean? Oh, sorry.
140 is the direction the wind is from, 25 knots, gusting to 35.
Okay.
That's the highest that station ever experienced as that passed by.
Through HELENE. Okay.
Correct. And that's right there. Okay.
That very moment. Okay.
So there was a gust to 45. That's the highest that station ever experienced. So the second place would be Williston. This is where it is. It's a little farther north, a little closer to where it was. It makes landfall right where that X is. So this is nearby. This one had Williston is 60. So here's the observations for that one. I'll zoom in and move this thing a little farther over to where you can see the wind speeds. The high was 27, gusting to 43. And there's a 46 a little while later. But you can see as you go higher.
This is all knots, isn't it?
These are knots, yeah. So that's about 1.2 miles per hour. So figure about 50. 46. And then dropping off. So that's at that station called Williston. Okay, let's go to Perry. This is the maximum. This is very close to where it made landfall. So this is Perry. It was just a near miss on that. This one's going to be the probably best case scenario, because once these things hit land, they get cut off from the moisture. They diminish in strength.
So, right. So the moisture's sort of driving it, and then land is an obstacle, basically.
And if you look right here, it made landfall about 230, and the highest wind speed you see here is 86, and that's a gust. And if you go back to the wind scales that we saw, I could go back to that if I need to here. Do you remember what they were? I didn't really cover what those speeds were very in depth.
When you say gust, obviously that means, you know, a quick bit of wind. Yes. Is there some sort of definition for the word gust, as in, does it have to be like
it's recorded by the anemometer? It just gets the peak wind as it whooshes by.
The maximum, yeah.
for lack of a better word, but tropical storm is 39 to 73 miles per hour. You got to be category 1. It's hard to convert
because that's miles per hour, and we're talking knots. So,
well, they're here on the scale of tropicals. Cool. Category 1 is 64 to 82 for knots. So we're looking at knots. 64 is the minimum in knots for a category 1. You don't have anything here. There's a 48 sustained. That puts you in tropical storm category at the city that's the closest to the hurricane, right on the coast, as it made landfall. This wasn't even a category 1 from the stations we've looked at so far. So
nowhere near it.
As I continue to go up through these other stations, I'm going to get rid of that guy right there and go back to the weather obs. And I was on Perry. So here's Lake City is here. And the Lake City information says, blow up here, slide her over.
You can make that window a little bit bigger itself.
Yeah. So there's a whole bunch of other information inside that, but the main thing we're looking at here is that this is an automatic machine recorded instrument, and the highest wind speed is 39. right there.
Not. Mm-hmm.
And if you go farther down to where I have it highlighted, I highlighted the highest, 57. We're not seeing anything that says even category 1. And this is as it made landfall. So without going into, I mean, I have multiple ones that help me to determine if it was where they say it was. So I'm looking at this data with a fine-tooth comb. I'm going to blow that up again.
Now, this data that you're looking at the moment comes from the NWS, is it?
Yes.
National Weather Service.
And it's at airports. So this is, you know, the places where the planes fly. This is for aviation.
Yep. Okay.
So when you learn about weather, you have all these things to help you identify where the cold fronts are, where the warm fronts are, and you look at this data. And if I look at this number right here, A is altimeter, 2850. And if I look at heavy rain, and the winds are the maximum right here, and the visibility is 1 1/4 statute miles, heavy rain and fog, overcast skies, temperature and the dew point are equal at 24. The pressure at this line right here is 2861, and the pressure on the next one is 2850.
Okay, so that's the pressure, 2850.
The pressure is dropping, and then it goes up to 2864. So this tells me this is getting as it is the closest to the as it gets to this station. That's the minimum pressure. So after that, it's passing by the station and moving away. The winds are super strong. I know that location is good based on at 0615Z. Tifton. I have another one right here.
Noob question.
Yeah.
If the pressure is higher, it's like a stronger force. Is that right? Or is that completely wrong?
No, that's right. If the pressure, the lower the pressure, the closer you are to that low pressure center, and that is a low pressure center.
Okay.
It's counterclockwise winds swirling about that center. You could see where my little X is right there.
Yep. So the eye
that
of the storm.
city is right here. Tifton is right there, that gray dot. So
Gotcha.
if you look at the winds on this app right here, you could see that, figure that the winds are counterclockwise around that. On the south side, they're out of the west. They're coming from the west. On the east side, where that X is, the winds are out of the south. On the north side of that low, that's the hurricane center. On the north side, they're out of the east. Let's look what they are at Tifton. When I look at these angles, I'm thinking that's a northeast wind swirling into that center. And if I look at 040 at 25 gusting to 40, that's northeast. So that tells me that this position is very good, that I know that that's exactly where this application right here is showing where it is very well. And I would check.
It's accurate.
Correct.
You can rely on that.
And that's what I'm doing through this whole process of checking all these observations. Like this was Lake City. Tifton again was right here. And I used 4 stations to actually go super duper into that data to ascertain that location was where it was. And when I go through all that data, I don't see anything that was anything that was above tropical storm strength. However, go ahead. You have a question?
I was just I'm just sort of wondering where they're getting all this category 4 from. That's all. But I guess we'll get to that.
Well, you're not going to see evidence of it.
I know. We'll get to the fact that it wasn't really there.
It wasn't category 4 from the minute it hit the coast. You had a gust to 89 or 8. A gust.
So the whole category 4 scare mechanism thing was all based on one gust, which was not even before it hit land.
Well, those hurricane aircraft were at 10,000 feet, all 3 of them. No, the first one was 5,000 when it was down by Cuba off of Yucatan. The second 2 were at 10,000 feet.
Yep.
I'm not sure how they predict the surface winds with that.
Yeah.
I
Okay.
was never a tropical weather forecaster, and maybe somebody that watches this can give an answer to that. But the winds were overestimated for overland, and I'm going to show you some. I don't know if I want to go through all of these other stations. I don't need to do that. That was.
Well, we know that you've been through it at quite detailed length, obviously.
Yes.
As a meteorologist, I'm going to be listening to you.
there was wind damage. I mean, I was talking to a guy that lives near Lake City as it was happening. I was texting back and forth with him, and he was saying, "This is going to be Category 4." I said, "No, it's not. It doesn't show that. None of the models on Ventusky," and I looked at all 5 of the models, and not one of them is showing that it's going to be more than 70. So he was there and telling me the house is shaking. I mean, he was having 50, 60 knot gusts at that time. So I'm not minimizing that wind was damaging. He showed me pictures of the snapped off trees all over his property. And it was like, okay, 60 is not fun. You don't want to be in a 60 knot wind, but it's not what was advertised. 140 is way less fun.
Yeah, that's the point we're trying to make here. And I want to make that really clear. We are not trying to downplay what happened here, because it was torrential. And it was terrible what happened. It was a horrible thing to live through. But, I mean, you guys, you get this every year. This is sort of hurricane season, right?
Mm-hmm.
You all have been through all this a number of times.
I haven't in California.
Well, okay, but all you folks that live in this sort of tornado alley area, this kind of area, you're kind of used to it. I mean, Florida, we hear about that every year. Even as an Aussie, I know about it. So the point we're trying to make here is that the media hype did not mention the actual storm hype. So that's kind of where we're coming from here. And we're trying to teach you guys also how to learn to read all this yourselves, so you're not actually relying on the hype. You can actually go and verify this stuff for yourselves. So that's our whole point of all this.
And I would like to actually show you that right now. I would like to show you how you can do that.
Please do.
So here's, I don't know if you can, how do I send that to you quickly? Well, we'll put it in the show notes, right?
Yes.
So this is called the FAA Surface Weather Observation Stations. So if I go into, I want to just see a particular state, I can click on that state. So let's just say Florida. And it's going to show all the cities. And if I know the city, I can actually enter the name of the city right here. But if I don't know the city, I'm going to say Florida again. It didn't, for some reason, it didn't do what I expected. And it's going to show the name of the cities below it. So let's say it was, again, right here, the one that had the highest winds was called Perry Foley, right here.
So these are all the cities in Florida. Okay.
This has 96 hours of data if you choose to do that. So it's showing, it should be showing Foley right here.
So a time interval of 96 hours?
Yeah. Well, you can get 96 hours of observations. So I'm going to actually go into and click to view Foley METAR data. METAR is the code that we use in weather. So you can get past 48 hours, 1 hour. So that's the last hour of observations that came out today.
Okay, so what does that tell us? That's the time, temperature,
dew point, wind speed, if there's gusts, if there's any weather, and if there's clouds, and visibility. So it gives you all that, but you don't have to learn METAR. You could say decoded and say load data, and that's going to break it down into
plain English.
Yes.
Okay, good.
Plain Australian, plain English. Yeah. It breaks it down very nicely for you into temperature, Celsius and Fahrenheit, inches and millibars. Wind is calm, no clouds up to 12,000 feet. But if it's an automated station, they can't do that. You have to have a human there to give you the cloud heights. Clear skies below 12,000. Automated observation with no human augmentation. It's a Android. So let's say I wanted to go 96 hours back, and let's say I like the raw data myself because that's how I presented it to you guys. Darn it. I want to go back. I want to say I don't want it decoded because I just like seeing all the data so I can scroll down and see all the way back 96 hours.
So it's your gibberish language now.
Yes, it's the METAR language. So you can
the
just see
Aussie version. The Aussie version just says, "All good, she'll be right. Put the Billy on."
The Billy. That's the first time I've ever heard that word. Coffee.
It's basically like a kettle over a fire.
Very interesting. So the breakdown of that again is the wind speed. 10 is 10 statute miles, clear, 24-degree temperature, 23-degree dew point. Altimeter is 29.92. And that's the basis of that. So you guys can go to any city that you want and click on any other one. So I could have gone to Apalachicola, or if I wanted to do Alabama or any other state, you could pick wherever you want and do the same thing to get access to that actual up to 96 hours of data, plain language, or METAR if you know the code.
Okay, so all these cities have apparatus to measure this stuff, yeah?
Yes.
And that's what we're looking at as all these measuring stations information.
Correct.
Okay.
So
so it's partly automatic or it's all automatic, or you said that you needed some person?
Some people, some airports, the bigger ones, like if I went to Atlanta, let me find Atlanta. This is DeKalb Peachtree Airport. That's Fulton Executive, Cobb. So one of these is bigger, I'm sure. Covington.
So assuming the bigger ones would have more sophisticated or more automated
you can have
equipment.
People. Yeah.
Oh, you're going to have more people. Okay, right.
You're going to actually have people doing it. So if you highlight it, it shows you which one it is. And then you float over it with your cursor and then go into the data. And you may actually have, clouds like here. You have it. So scattered means less than half of the sky. That 047 is 4,700 feet above ground. Scattered at 6,500 feet above ground. So you've got 2 layers of clouds. On that last one, you have a few clouds at 7,000. So there's a person here making these estimates. So those are better.
I suppose that's a good thing.
It's better. Well, you know what? I am getting myself in trouble right there because it says auto. But how?
Yes, so it does.
They might have possibly what we called back in the old days a RBC, rotating beam ceilometer. It casts a strong light up into the sky and it reflects back and it estimates the height. They may have that at some airports still. I would have thought that was way gone, but
it estimates the height of the clouds.
Yes.
Okay.
Based on
and it's just timing, a light,
like radar.
Signal.
Yeah.
Okay.
They call it a RBC. Those may still exist, but my point here is the bigger airports, they have people. It's not auto. This is, a wind gauge, a thermometer, a thing that measures the dew point, and the altimeter. So that's your typical automated station.
This is all going to be like super accurate because the aviation industry relies on this information. Is that correct?
Yes. These instruments are housed in a specific little box with louvers. It's shaded so the wind blows through. It's painted white so it doesn't heat up. They're very specific as far as where those instruments are located. They're not in the sun. This is the way of the observations throughout the world.
Yep. It's the go-to, and it's very important that it's accurate. All right. Just wanted to establish that.
So that helped me to determine that that track was actually where it showed. So if we go through that track again real quick, if I scope my way through this at 3 hours at a time, you can see the path, and it ends up by over a 12-hour period right here. This is 0300 and
UTC.
yep,
Salute.
UTC, and you go back and it's at 1500. It's already leaving Tennessee at 1500.
Okay, before we go on, can we just try to sort of bring some light into the gap of UTC and, I mean, this is what time are we going by here? Eastern time, isn't it?
Right
Like
here.
for the Americans to understand.
This is where I am. This is my location.
Okay, but like local time there would be Eastern time, is that right?
Yes, Eastern
call
Standard
Eastern?
Time would be +5. If you went 5 time zones to the east following the sun, you're 5 hours behind London as far as light goes.
So 5 hours behind UTC, is that correct?
Correct.
So if we're 3 o'clock in the morning UTC, we're 10 o'clock at night the night before Eastern.
Yes, for
Okay, just wanted to establish that. That's all. Thank you.
Correct. So that shows the locations, and I confirmed it with using those observations, the pressures and the temperatures and the wind speeds. So I want to also show you a look at this. This is another way to confirm it. I have this set up using the archived imagery, and I set the start time and the end time to show the clouds along that entire 2-day period. So if you look down below, it's got land temperature is the dark blue. So this is cloudless. Snow, there's no snow, would be dark green. Glaciating cold means below zero but not frozen, was that green that you see throughout there.
Mm-hmm.
Low water clouds are the blue. Thick high clouds, ice clouds, are yellow. And thin high clouds are red. And then you got a purple way to the right, thin mid-water clouds. So there's a little bit of purple here or there, like off of North Carolina. But what's important to see right here is, I don't know if I finished saying what I wanted to say about the low. I think I got sidetracked on that. The low that was cut off. Wind speed, go back to this. I want to show you, this is really, really, really important to get what I'm going to tell you right now. So on the 27th, Helene is there. You got this low spinning. This is 500 millibars. This is 1500 when it's just leaving Tennessee. And you've got this huge upper low spinning with the winds coming, spinning around it counterclockwise. So at this point, all of the clouds have been sucked into that low. And if you look to the right, there's not an H right there, but this is called a ridge of high pressure. So things are, as I call it, lazy. They're going to go with the path of least resistance. So as that thing tracked up, as that very good sized storm tracked up, here's low pressure, here's high pressure. Which way am I going to go?
Mm-hmm. Okay, I get it.
That influenced the track. And it influenced it to go right over the tip of South Carolina, over the western tip of North Carolina. And what is there? What is there? The Appalachian Mountains.
Can make that a little bit bigger, please? You can make the actual window bigger as well. Be good.
Yeah, I'll just do the whole thing right here. I'll blow the whole thing up. So there you have it right there. The Appalachian Mountains run down into Georgia, into the very tip of Georgia. So for anybody that's watched our previous videos on clouds number 2, I talked about the things that make cooling of an air, of air, and rising is what it takes to make something cool. So when you have a tropical storm coming up, going through Georgia, right here in the tip of South Carolina, winds are counterclockwise around it. Everything coming around that right side of the low is going right up the slope of those Appalachians. That's called orographic lift. That's based on topography.
Orographic lift. Okay.
Orographic lift. That's topography. I've got.
So that's the mountains pushing the air. Well, the air can't go through a mountain, so it gets pushed up. Yeah.
Correct. You have 30 or 40 knot winds, and this is showing. This is Mount. Okay, so Asheville is right here.
Okay. Asheville, Northern Carolina.
Yep. And if you look down, you can't really see, but this is Mount Mitchell. I want to give you a different view of that first. Hold on. It's going to show you. I want to show you. This is data from CoCoRAHS on the 27th, ending at over on the left. It says between 4:30 and 9:30 local observation time. This is the volunteer network of observers throughout the world. I mean, Canada, not the world yet, but throughout the United States and Canada.
Local time. Okay.
Correct. So 24-hour period, this is the rain measurements for that period of time. If you look at the one that I have highlighted right here, I clicked on that one. That's 11 inches of rain in that 24-hour period. Here's another one, 8, 6, 7, and then you got lower numbers over here. So that map doesn't really show you what you want to see. You want to see it with topography. Now you add the mountains in right there. And Asheville is right here. And these numbers
so
are all
sort of right at the foot of the mountains, is it, Asheville?
Exactly. You're making that air rise as those winds are spiraling around that low. They're coming and going directly up that. And the more perpendicular that happens, the more you're going to wring out of that rain by lifting it up the mountain. It makes it cool. If it cools, the temperature becomes equal to the dew point, drops to the dew point, and it rains. So you're going to see that, like here, you've got mountains over here, but you have less rain. And if you look back farther out, you could see that down in Florida for that 24-hour period, the numbers were very small. And this is right next to the ocean. And you look at the numbers near the ocean, and they went away. Why did they go away?
Yeah, they went away. Oh, there we are. Okay, so let's talk about the color coding here at the moment. Can we just, because I can't quite see that chart. Do you reckon you could zoom in on that chart for us for a sec? That legend
I can.
on the left.
Yep.
Just for a mini, have a look. Awesome.
And when you zoom in, though,
we're talking inches here. Okay, you imperial people.
When I scroll in, the numbers become apparent, though.
Yeah.
And now it's not working. Oh, wait. That's fairly silly how it's not. I think I just need to refresh this. I'll refresh it, and I've had it open for a couple days. This is the app called CoCoRAHS.org. So I'm going to go back in here right here and get back to the same part of the world and go back to the date that we wanted, which was the 27th after the hurricane passed.
Okay, this is afterwards. All right.
So those numbers are floating. That's not always the same, but you could see that the reds are 7.98 to 14.85 on this day.
All right, so that's all I wanted to know, was that the red is the heavier rain, then we go down to orange, and then the blue is lighter.
Correct.
And white
if you
is
notice,
0.
Relative to those mountains, where is the heavy rain on the approaching side as they're coming up the hills? So whenever you have hills or convective activity right next to the low, I mean, it was that spin was right here because the location was here. It was lifting up over the mountain right here and then
Yeah.
raining down here to the south because the wind speed was going up the mountain and then coming down, and the rain was raining out. So anytime you have orographic lift, that's going to ring out the actual the wetness in the air.
Right. Well, it's sort of that simple, really, in one way, isn't it?
And I'm going to show you the Radisson data, which is one of my favorite things to talk about.
You do love your radio sonde E.
Radisson E, yes. So you have the surface observations are a part of it, but right here I'm going to click on Atlanta, and it's going to give me the current one. But I want to go back in time to
Yes, we need to travel back.
1727 So you get about 2 weeks of history right here. You can go back.
That's good.
And if you look at that, you have the temperature and the dew point are the two numbers, the two lines. The temperature is the blue, the red is the dew point. When you have less than 5 degrees, that's when you're forming clouds. Right here you have 3. And if you look all the way up, you can see those lines are right next to each other all the way up. And there's a calculated point called the LCL, which is the lifting condensation level. If you lift the air 1,096 feet, it's going to start to precipitate out based on those conditions. And you have something else called the temperature of convection, 71, and the convective condensation level, which is 939 feet. So anything at that time, as this Radisson was released, that evening, which was when that storm was coming on shore, that air mass would have been ringing out the precip based on lift at around 1,000 feet. And those hills around there, if I go back to that map, I need to go to, and this cursor, wherever I put it, it shows the elevation. Mount Mitchell is right there. Mount Mitchell is 6,149 feet. All these areas right here where I have the cursor, the funny looking cursor, 3,431 feet. Way down at the edge of where it comes into Asheville area, those are all 2,510 feet. And over here to the left corner, that's 2,300 feet. So all of this is upslope. And that's a river, that green thing. That's outlining the river. So where does that river go?
Yeah, exactly. Okay,
right,
so from a noob point of view, we've got Asheville is battling with mountains that are pushing the air up, creating the precipitation, which is then coming down, flowing down off the mountains, as well as filling up the rivers that are then collecting into Asheville.
Yep.
So that's a lot of water. Yeah.
And
it was just, wrong place, wrong time, I suppose.
That little dash, that dark, the green outlines the river. And it looks to me like it runs right through town. It runs right through Asheville.
Yeah.
Looks like downtown's right there. The green boundaries right
Makes
underneath
sense.
the
I mean,
freeway.
they normally build towns right next to rivers for obvious reasons.
Yep.
So in the old days,
based on all that, you had the storm coming up right into the southern end of the Appalachians, giving a whole bunch of orographic lift, and then turning to the left and going west based on where that low pressure was and away from the high pressure. That's what caused that.
Yeah, okay. So based on the atmospheric situation that was around the storm, that's what pushed it to the left.
Correct. That synoptic situation, as I mentioned that word, was low pressure over the 6-state conjunction near Tennessee, Kentucky, Ohio, Missouri, a whole bunch of states come together right there. And that low was right there. Yeah. And it was coming up, and it could go, I'm going to go against the hill to the right where there's warm air. I'm going to go towards that cold air. and it went towards the lower pressure and hooked to the left, right over the Appalachians, which caused the conditions to wring out that extremely moist area.
Yep. Okay, so what we've sort of shown today is that it all made sense. There were reasons for all these things that happened. There was nothing mysterious. Would that be a fair thing to say?
If you know weather.
Yeah, if you know weather, obviously. A lot of people don't know weather to the same extent that you do, which is why we're here listening to you. Before we move on, is there anything else you would like to show us in this regard?
Just to quickly go through this, I want to go quickly through this thing making landfall right here. You could see the eye yet. See the dark spot right there near Perry? Perry would be right here. Lake City was there.
Can I ask you a question, please?
Yep.
What do you define landfall as? Is it when the eye hits the land?
Yes.
Okay.
That's the position that they give of the storm, the eye.
Okay, right.
So here's something very weird happens right here. You can see as this thing continues to the north, you lose the eye. The water flow is now cut off as it's moving inland. It's no longer getting moisture because the main upflow is right near that eye wall. And
right,
it's moving inland.
That's what draws everything up. The eye draws things up.
Around that eye is the maximum convection. That's correct.
Okay.
So you could see the eye is still, you can still see it. One of the cities was Valdosta, and it continues tracking to the north. But you'll see right here, it looks like it deviates from that path that we saw outlined in Ventusky. Right now, it looks like it's going through the center of South Carolina, right over Jim's house, Jim Lee of Climate Viewer.
Yes.
Sumter's right there. Hi, Jim. So it looks to me like they screwed up the path, but I verified the path using all that observation data by temperatures, pressures, winds, directions. That path says that it's up over at 1500. Right here is 1300. It should be up near Knoxville, Tennessee. It doesn't look like it.
So why would we be seeing this? Isn't this like, what are we looking at? This looks like a satellite type thing.
Yeah, this is the RAM slider. So that's showing the nighttime view. It doesn't have color at night, but you can see the sun's coming up and you're starting to get color. This is 1400 UTC, and you're starting to get color again. And what you see standing out there is the blue. That's your low clouds, low water clouds. And the upper stuff is stripping off to the east because that rain, if you look right here, I don't want to zoom yet because it's going to take a whole bunch of time. There's a little comma shape right there. I'm going to zoom in here in a minute, but as I go a couple more hours right here, I'm going to click 2 or 3 more times. That's a half-hour increment. I can see that there's a circulation right here, and you'd only see it when it comes in, when I zoom in, but the clouds are circled right here. That low, based on the location of the low clouds, is right here. Everything else up top is stripping off to the east and splitting to the low right here. You got that big upper low over that conjunction of those states right there, sitting parked there lollygagging, and you have all the low moisture that just fell out, very apparent through that entire area, that light blue color, and the high clouds are ripping off to the east, and some of them are going back to the east or to the west as well. So if I just click through a couple more times, I'm going to zoom in and show you that you could see where that low is based on the cloud types. Look at the swirls right here in the low clouds.
Oh, yeah, okay.
So it looks like the storm went not where it was, but all the observation data and everything along with it, you could see the circular swirls right here. And if I hit play It probably won't right away because it has to reload based on this data set, which is different than it was. It might take a minute or something, but you could see the swirls, the low would be right here.
And again, just while we're waiting for this to load, again, I'm just going to sort of reiterate the brilliant piece of information that I think it was Jim that said to me. Just, think of the sky as like a river, basically, like water, fluid, like it's going to have the same kind of movement as you would observe in a creek or a river. Similar sort of movements. So, I mean, once that was said to me, it made things make sense. It's like, yeah, of course. I mean, it's all moisture up there, so it's going to have a similar, the way water moves around and swirls, etc. It's going to be doing the same thing up there as it does down here.
It's fluid.
Pretty much.
Yes.
Within reason.
So here we go. Look at, you can see those low clouds in the swirl as that low tracks to the north. And at that point, it's just a tiny little spin with not a lot of wind as it passes by this point, but it continues to just become a part of that big upper low, and the hurricane is no longer, not even a tropical storm. It's extra tropical at that point when it gets up into Kentucky.
Yep, getting down there on the scale, but it doesn't mean there's it's still a lot of water, raining, etc.
It already dropped it out on its way over the Appalachians, and that's what wreaked all the havoc in the Asheville area. So that enhanced area of dark light blue is where the low is, despite the fact that it looks like it comes up through South Carolina and heads up to North Carolina and to the east. And you can see all the waves and the clouds over the Appalachians as well. Those were lee clouds happening that you just saw right there. You just saw the ripples, the mackerel sky.
It would have been amazing to look at.
It would have been beautiful, yeah. But I mean, yeah, what just happened there was terrible, but
beautiful but deadly.
So I don't know if there's anything else that I had. Let me look back at my what else did I want to show you? I had a lot of screenshots, but we just did everything with the live apps. It was a lot easier than going through all this stuff. I think.
Good to be prepared.
Well, the one thing I didn't go over was the National Weather Service statements. So I have these sequenced for what they were calling for, and I've got little reminders. So on the 26th at 5:48 p.m., South Carolina was calling for, I'll zoom that up, zoom it up. This will likely add an additional 8 to 10 inches of rain across many locales and produce high-end flooding, which may require flood warnings with the emergency designation. So this was, the day before, and they were talking about, this is the forecasters for South Carolina. So that's one.
Yeah, so it's about 6 p.m. the night before.
Yep.
They were giving out those warnings.
They were still calling Cat 4 on this previous one. And that was, after, come on, open up. This is 5:05 a.m. on Thursday, the 26th. They were calling for Cat 4, major Cat 4 hurricane.
What date was it that it came on landfall?
Thursday, the 26th. So it came on like 4 hours after this, but Hurricane Helene will move onshore in the Big Bend area and continue northward with the tropical storm force winds affecting sites overnight. Sustained winds 45 to 50. Does not jive with Cat 4.
No. Nowhere near it, really.
I find that bothersome. That's tropical storm strength winds. They just said it right there before it came on shore. And the stuff that we were seeing on the internet, as I call it, fear porn, it was pretty tremendous.
Yeah. That was everywhere. It was all over the place. So that's where I'm trying to get to is why? Why do you think Everyone
Clickbait.
was...
Clickbait.
Yeah, but like, can I just share my screen for a moment?
Yep. I'm
Just
gonna
going
watch
back
you.
to this thingy. Because we're talking about news channels as well. I mean, I guess there's nothing to say that news channels aren't going to be involved in clickbait. Of course they are. But I don't know. I guess in my head you kind of expect something a little bit more professional from actual proper news channels as opposed to the dude that calls himself a meteorologist standing in front of a map. You know what I mean? There's a lot of channels like that on YouTube. But I mean, this is CBS, for instance. We've got Category 4, you know. CNN, Category 4. They're all getting their information from the same place, correct? I mean, there's only
Correct.
one sort of central place you can really get it all from, or the feed comes from, right? Which is the National Weather Service, ultimately.
Well, those updates, there are National Hurricane Center updates that I had in that group right there. I didn't get to any of them, but there needs to be really good coordination between them and all of the local forecasters, because you have regional offices and those forecasters tell their reasoning in the forecast discussion. It's a write-up that they do. There might be, I don't know how many there are across the country, 10 or 20, 30, I'm not sure, but every region has their own set of forecasters and they write those area forecast discussions. I was not seeing good coordination between what the National Hurricane Center was saying, Cat 4, Cat 4, Cat 4, with what we just read right there, which was the South Carolina people saying 40 to 50 knots. That additional fear did not need to be there.
Yes, that's the point. It's like, you put it very well, it's like coordination sort of somehow flew out the window. That this Cat 4 thing took over so much in the media, and nobody really modified it from that point. It's like they went with the Cat 4 and they were sticking with it. So that's the
And
point of what we're trying to get across today is...
can you scroll
like,
back? Scroll back a little bit.
yep, you
Right
tell me
there.
when.
Look at
Here,
that
this
right
one?
there. The gusts.
Gusts? Yep.
Perry. Douglas. Those are places I looked at.
Mm-hmm.
I didn't see 99 at Perry. I saw 89 on those observations that I had, but that's ballpark. But guess what? You have to have sustained to be considered a
Yes.
tropical
Now,
a Cat 1. It's got to be above 74 sustained.
it's got to be sustained for how long? There's a certain amount of time, which
1 minute. I think it's
1
1
minute.
minute. Yep.
I think you're right there. Yes. So that's... did we go through all that? That's showing all the different categories.
I did not. That was all in the write-up. That was in that section, though. It was in that Wikipedia thing, and they actually did a good job.
Oh yeah, we showed that table. Yeah. So look, I mean, it's no secret. Well, I don't know, maybe it is still, but certainly not to some people who are starting to realise there's another thing of wind gusts there. Perry's not actually on that one. That's the guy that should have the bow tie. Yeah, it's like the coordination went out the window and they've just jumped on the bandwagon. What I'm getting to is, it's nothing new that the whole climate change agenda thing is pushing so much of what's in our lives these days. You know, these self-appointed corporate experts have decided that climate change is going to kill us all, and grandma, and that, you know, we all us peasants have to stop using our gas stoves, etc., to save the world. And to me, this is just yet another example of the fear porn bandwagon, not only just for clickbait, but it also adds to the collective psyche that the world's going to crap. And here's an example, because this Category 4 storm it's just not letting up, you know. It's like, well, no, because if they'd have actually told the truth, they would have said, look, it's looking like a Category 4 storm, but now it's downgrading a bit. Now, I don't know whether they're worried about people perhaps relaxing if they do that. That's me giving them some credit. But personally, I think it's just yet another another stone in the path of this climate agenda, which is trying to convince us all that, we're all going to die unless we make all these massive changes. And see what this storm did. See what we're telling you is right. You know what I'm saying? It's like they're just trying to feed the fear train, keep it alive and well.
And it's human caused.
Yeah, that's the other thing. Yeah, it's all human caused because of what we're doing. This all happened. It's like it's just they're not actually saying that, but that's the picture that they seem to be building. I mean, that's pretty unprofessional what happened, really, in one sense, isn't it? It's like they're trying to let us know this is going to be a big, heavy storm. And yes, it was. It was. But it wasn't a Category 4 storm at any point. It's not worth putting headlines on and huge graphics on screens. There's only one reason they'd be doing that. And even this guy here, hang on, let me just show you this guy. This guy here. This guy. It was funny to watch him. He was the typical weather guy who was out in, he was in a bit of a windy place for sure. But he was sort of making it look worse than it was. Like he was really acting, like trying to hold that on. And it was like, oh, I got to get it back inside.
Was he doing the lean?
Yeah, that kind of thing. Exactly. It's just kind of funny. It's just like they're all just being told to play it up. That's what it just feels like to me. And they're
your
not
job
really.
Depends on it.
Yeah, exactly. Your mortgage. Don't forget your mortgage. So I don't know. What we're trying to do is help people to learn to look at the facts themselves, not just look at the fear porn, look at the YouTube videos, look at the mainstream media, because it's no secret now that people are waking up to the fact that mainstream media is not what it appears or what we all thought it was all these years. It's a monopoly that's owned by corporates. And it's all a script. We've all seen the video getting around of the newsreaders saying exactly the same things in unison because it is all a script. I used to do community radio and we would get the weather script, and which was fine. There's nothing wrong with that in the sense of that's the weather, that's the facts that came from this one headquarters. So that's fine. But when it starts venturing into the news being scripted like that, plainly, it's propaganda. There's no other word for it. They're controlling the narrative, and it's that simple. I know this is old news to most of the people probably listening at the moment, but there's new people coming into the Climate Viewer group, and we're seeing the responses of, a lot of people, like myself included, not that long ago, were angry. We're angry at the sky. Oh, there they go again. There they're doing this and whatever. And then you start to learn a few things and you start to realize that some of that apparatus hasn't got the capacity to do the things. Like, for instance, the whole NexRad thing. The radar just doesn't have the capacity or the power to move, because I think the thing that people are missing is the weather up there is incredibly powerful. It's like megatons of, the equivalent to certain nuclear bomb sort of thing, if you want to put it into some sort of scale. To move weather systems and to influence things like that would take an incredible amount of energy and output. So the anomalies that people are seeing are just, it's misunderstanding. They're not nefarious by nature, I don't believe. Not us people, like they TM sort of to a point, very self-orientated motives. But generally, the general populace, we just need to be educated. We haven't been educated about any of this. It's sort of like, the Gutenberg, once the printing press came along, people were able to read and see some of the information for themselves, and they weren't just victims of the pulpit anymore, being dictated to. So that's what we're trying to bridge, that gap of people. Instead of being told what's happening, let's teach people enough to go and look at what's happening. Let's look at the evidence, put it all together ourselves. You don't have to be meteorological level like Jeff here, but at least to just be able to look at some of these things and understand for yourselves. I think educate yourself, basically. If you pull the plug, we're going to have to deal with a lot of things ourselves. So let's be less reliant, because being less reliant on the system is less vulnerable to the propaganda. So, I just think That's where we're at, and that's what this was sort of about.
And
Yeah.
can I say something there, Stella?
Please.
So you can be, like Stella just said, more self-reliant by using an app like Ventusky, like using the app that shows you the observations at the city nearest your house. You can actually just check that stuff yourself without having the knowledge that I have, but there's the plain language thing to that. Select your airport, select your station, so your city, whatever it was from that map, and you have data for 96 hours of observations in plain language mode if you choose. And if you look at the Ventusky app, there's a tab called precipitation. You're going to know when it's going to be raining, and it's pretty darn accurate. So you're going to know what your wind speeds are, all that stuff. When the clouds are going to be there, I use it to forecast contrails. It's like I can look and put it in the mode that says clouds, high clouds, and know that the conditions are going to be there for contrails the next day or 2 days or 3 days out sometimes. There are specific places where the contrails happen. And I also like to share my screen one more time, Stella, please.
Yes, certainly. Just give me 1 sec. Yeah, because all that information is live, isn't it? It's not.
It is.
It can't be tampered with at that point. I mean, we all
Correct.
are starting to learn that the long-term records have been tampered with. Absolutely, 100 billion% they've been tampered with to support the climate change narrative. And I'm talking the records over centuries type thing. So when you look at the graphs, they're not true. They're not true what they're showing you at the moment. They have been altered, and they come up with stupid, weak reasons, but they have been. And I highly recommend the channel on YouTube called Tony Heller. He brings some
excellent.
He is so good. He has these little sort of they're short bite videos, maybe 5-6 minutes. Some of them are maybe 10 or 11, but they're really, really good to show in plain black and white how the graphs and the statistics have been altered over time to support the current narrative. So Tony Heller, shout out Tony if you ever hear this.
Stella, do you think we're over 10 minutes?
Yeah, maybe. We could make this into a 12-part thing, but no, that's fine. It's important. I think it's important we go over all this sort of stuff.
There's
What do
something.
you want to show us here, Jeff?
Do you see my screen right now?
Can do. Yep.
Okay. I talked to Jim Lee before the show today. I wanted to pick his brain on. I wanted to tell him where I saw those hurricane aircraft penetrating the storm at 10,000, 5,000, 10,000 feet, and wanted to know what he thought about whether they could be put in black carbon dust into the thing to alter the strength of it. And he shared a couple things with me, several things actually. And I want to share a couple of those things right there that were pertinent to me, and anybody can do this.
Jim Lee's climateviewer.com. Highly recommend. Brilliant website. Everything you could possibly need to know.
Anybody on weather modification, if you see right there, weather modification history, that's Jim's.
Oh, he's brilliant. I love that place.
He's got the history, the timeline. So the things that he shared with me, I wanted to know where an aircraft would have to be to do black carbon dust. And he breaks out papers instantly.
Black carbon dust. Now, is this the military stuff?
This is the manufactured stuff. Yeah, it's not carbon. It's not natural
not carbon. Black.
Yeah. But he shared this with me. This was in one of the papers. It's showing the Global Hawk, which flies up at 50 or 60,000 feet. It's able to get over the top of that. Most aircraft can't. That's a 50,000 foot top to that hurricane that we just had.
Okay, so what is the Global Hawk?
Global Hawk is just a type of an aircraft that flies really high, and there's like one stationed over the Middle East a lot of the time. If you were to go on flight radar and set a filter for 50,000 plus, you're only going to find maybe one or two aircraft the whole world that are flying that high.
Okay, and what is the purpose of these aircraft?
I thought reconnaissance, but could you modify that to drop black carbon over the top? Not sure. I'm kind of like, I'm not the expert on this stuff at all. I stick to my weather. I stick to my lane. But Jim is, and here's another thing that he shared, and this is very interesting.
Sorry, what? So what? He was showing us the fact that there was a plane over the top at that time?
No, that was, well, I'm not sure if that was animation or what, that particular one. I have not read the paper.
This is the plane that would go that high to be able to do this. Okay, gotcha.
Correct. And then you have the C-130s. That's what this is showing you. And it's a cargo aircraft. And they're showing how to halt a hurricane. He's got an animated GIF that shows this. Fleet of transport aircraft flying at 50,000 feet drops soot into the path. Now, there aren't that many aircraft that can fly at 50,000. I'm pretty sure a C-130 can't. But they're showing here 4 aircraft flying the hurricane, and supposedly by this process, soot is warmed by the sun, heating the cool air around it at the very top of the hurricane. This reduces the flow of air within the hurricane and slows it down. That clearly is not what happened in this case. That thing was booking at 40. That was not a case of slowing down to suck up the warm water. It made a beeline. It was come and gone from a day and a half. It was, from Cuba to Tennessee.
That's being extremely optimistic too, isn't it? It's sort of like a few planes. I mean, they say fleet, but as you've just stated, there's not that many planes that can get up there. But anyway, let's assume there's a fleet. It's kind of very optimistic, isn't it, that drop a bit of carbon stuff into a hurricane to slow it down. I don't know.
But you never know.
Good luck with that.
You never know. And when you go to flight radar, what I did to find all those flights, I went and actually did, is this a screenshot or is this the actual app? This is the actual app. I want to refresh this. And it's, Huh. That's funky.
What's that?
Sorry.
That's all right. I'll let it spit.
He did a contrail. So here we are. Yeah. I think we're getting live here. What is this? This is not right. This is not working. It never opens up to this.
I have a question while you're doing that.
Okay.
What we were just looking at doing, dropping the carbon. Now that was an animation, obviously. Maybe I should be asking Jim this question, but I want to know is, do you know, have they done that successfully in the past? Have they dropped carbon into a hurricane and slowed it down? I seem to remember there was something decades ago, but I'm not sure if they actually did it and what the outcome was.
I can't answer that. That's Jim's.
Okay.
That's out of my lane.
All right. I might do a call in or something to Jim one day and ask him. Maybe he can address that.
Where I was going with that, Stella, is this app, Flight Radar 24. When I went through this, I looked at the day and a half period for aircraft flying into that, and that's how I found those hurricane hunters. So
yes, you did.
I set the filters up like this right here: U.S. Air Force, military, NASA, drones, military gov, 50,000 feet. And you can set all those filters here, and then you have the playback mode if you have the gold version, which I have.
Yes.
And you can set it back to any date. So I went to the 27th.
This is Flight Radar 24.
Flight Radar 24, yep. So October back to September 27th. That's when it made landfall. So this is too late. I want to go
26th.
This is about the time it made landfall. But I want to say the 26th and start playback, and it will show me, and I can adjust the speed over here.
Mm-hmm.
I'm going to go, I look at it at 300 times speed.
So it's the speed of the what?
Of the playback of all these aircraft. These are the military aircraft that I identified. Okay. Yep.
Gotcha. Yep. Speed of the playback.
So You know, like that guy right there. There's your NOAA aircraft right there. And if I click on it,
Yep.
oh, that's not the NOAA. That's the Teal 73. That's the third one. And it shows
Lockheed
you a
Martin.
trace of where they went. And they disappear for a minute. So
Because they're changing. They must have gone below 50 or something.
below 10. If it went below 10, it doesn't show up because that's how I have my filter set.
Yeah.
Not knowing at the time that 10 was the speed that would be, or the height that they were at.
Altitude. Yep.
Yep. So there he is right there, and it shows the path that he was taking. So you can do this yourself by setting the filters up, learning to do this application, and watching for aircraft. So I, in the future, will be looking at anything above 45,000 feet overflying a hurricane, because what are they doing? Why would you be doing that? There's not many aircraft that can fly that high. The Lears and the business jets and that type of thing, they can, but that's not everybody that can fly above a hurricane.
Yeah, that's the elitosphere. So if there's going to be planes, I mean, even the elites aren't dumb enough, or are they? I don't know. They wouldn't fly over a hurricane, right? So there's only one reason that you'd get a flight above 50,000 over a hurricane.
They might want to take a shortcut. They might want to take a shortcut and fly over it because they can, but
pretty risky.
They got to get air traffic control allow them to do that.
Yeah.
You just don't get to fly the way you want. You're put on one of those lines. You're on one of these lines on this thing. Those are the jet routes.
Okay.
So like if you watch this, if I was looking at commercial, the hurricane is still way down off of Yucatan at this time. These, if I didn't have military selected, these two lines right here between Louisiana and Florida, that would be full of aircraft.
Yeah, right. Okay. So yeah, it's like the roadways of the sky. There are certain places that you fly and there's certain places that you don't, and certain routes that you take. It's not just random. I mean, I know that's stating the obvious, but it's not that long ago I didn't realize that. So I'm just saying it. So yes, they're allocated to fly on certain flight paths. They can't just fly around wherever they feel like it.
The roads of the sky. Yep. So these are like the military aircraft and the high altitude balloons that we're seeing right here, and it tells the altitude.
Highway. Yep.
So that was all I wanted to say, that we can watch for the things like black carbon by watching Ventusky to see who's where.
Yeah. So everyday people like you and me, us peasants, we can watch them watching us, watching them watching us, watching them. Yeah, no, it's good. It's and you know, you can even do that with the free version. You don't even have to spend a dime on these apps, because they give you a lot of, you know, generous amount of information for free. It's just if you want to up the ante, you can, and it's not even that expensive. No affiliations, by the way. Although open. Mr. Flight Radar 24, if you're listening. No, just kidding. Seriously, it's awesome software. We're we live in an interesting age in that sense.
Here's an interesting thing right here. If you go to playback mode,
mind-blowing, isn't it, how many there are?
If you say start playback, it gives you a count of aircraft in the sky.
Oh yeah. Is that right now?
1,439 in view at the current moment.
1,000. Wow, that's a lot. How don't they smash into each other?
They're on highways routed by air traffic controllers.
I wonder if they get flight rage. Pilots. You bloody idiot, move over.
So
there goes a little old lady in her drone on a Sunday.
There's a good example right here. Look at you got 3 aircraft in a row, all on the same highway. Yeah, and 2 more that are coming onto that highway. 2 more going that way. And these guys right here are coming towards each other. Their altitudes are different. This guy's at altitude of, say, 37,000, and this guy is at 38,000. So there's 1,000 feet of separation going opposite directions, same road.
Yeah. And that's something I'll take the opportunity to say as well, because that's another very common misconception that gets bandied around the place, around this joint, is people will say things like, well, how come that plane is doing contrails and yet that plane at the same altitude is not doing contrails? And it's like, okay, so did you have flight radar and you know they're at the same altitude? Oh, no, just I can see it. It's like, no, you can't. Because from here to be able to pick two planes 1,000 feet apart, there's no way you would be able to, unless one was doing contrails and the other one wasn't, because that's the only giveaway, isn't it? So the reason that a contrail happens is because that particular conditions at that altitude is correct to be able to visibly see a contrail. Whereas the other plane that looks like it might be close, but it's actually another 1,000 or 2,000 above, isn't doing a contrail because the conditions are different up there.
Yep.
So these people who sort of think that they're watching two planes at the same altitude and one's doing contrail and the other one's not, you'll find that if you get your flight radar out, they won't be at the same altitude. For two reasons. One, because otherwise they'll probably smash into each other. Actually, that's the only reason. So there you go. It's good to know these things because it takes the mystery and the fear a little bit. Once the mystery starts to dissolve, so does the fear. So
the way
that's
I
why
think
we're
of
here.
this, when I was seeing in another group that I belong to on Telegram, I was seeing people saying, I can't go outside because of the chemtrails. And they were sending pictures and it was cirrus clouds.
Yeah. Yep.
It's like
That's
the fear.
Yeah.
I said, I gotta somehow make people not afraid. And Stella came along and said, hey, you want to do weather with me?
Let's go and kill some fear. Let's save the world one idiot at a time. But no, it's true though. There's nothing worse than being stuck in fear, especially when it's unnecessary. I mean, there's enough stuff to potentially be in fear about without having to add to it unnecessarily. And once you strip the fear away, it gives you confidence to not only have a life, but also enjoy it. I mean, when it gets to the point where you're not going outside because you see a few lines in the sky, that's a really sad state of affairs. That's actually chronic. So let's try to kill that immediately. And yeah, we're here to educate people so that you guys can all know more stuff without having to sit through hours of videos like this. We're here to guide, not show.
You just have to sit through this 2-hour video to learn.
Well, we try to make it a little bit interesting along the way, but it's like anything. You've got to do the grueling stuff to get good at something. It's like learning to drive a car. After a while, you're not really even thinking about it. So, I mean, you should be thinking a little bit about it, otherwise you smash into things. But yeah. Anyway, I think that's pretty much shown people some good things there. And just a really, really quick history of propaganda. I mean, we've all heard of Sigmund Freud, the father of psychology. He's got an interesting gene line. His genetic line is quite interesting. These people like to keep it in the family. His nephew is Edward Bernays, who is then the father of public relations. That's what I was looking for. Edward Bernays wrote the book called Propaganda. I mean, 1919 was the first time the word propaganda was actually coined by Edward Bernays. Propaganda was highly used throughout the World War I sort of era to, we're talking modern times. I mean, it's older than that too, but modern times. It was used in World War I to basically to sell the war to American people so that the people would, go along with it all. And it worked so well that once the war finished, he went, well, hang on a minute. Maybe we can, that worked so well, that propaganda thing, that maybe we can apply this to advertising and marketing and on the domestic level. It's like, excellent idea. So that's what happened. And then Edward Bernays has also got a nephew, grandnephew, great-nephew. One of them. His name's Mark Bernays Randolph. And he, the nephew of the propaganda father, is the co-founder and CEO of Netflix. So that should speak volumes. Now, you can do a bit of research and, you can see all the things where it says, oh, well, just because his uncle was the father of propaganda doesn't mean that it had any influence over him on Netflix. No. Well, actually, let's take a look at Netflix for a minute. It's got all the things on it that are just basically predictive programming. I mean, how many of these movies come out and we can all see it being acted out on the stage now? It's like life imitating art. Funny that. If we want to know what's happening, let's just go and watch The Simpsons for a bit. I mean, that's all propaganda. It's all predictive programming. It's all, if you want to get into the esoteric sort of levels, it's all them. It's us giving consent by doing nothing. And what that does is it removes the karma from them, if you want to look at it on a spiritual level. But we're not really going to go there today, but that's what it does. So it's about being aware of the propaganda and rising above that, because the Holy Grail is space, right? Space, the final frontier. Space, the final frontier. The space they want is the space between your ears. That's the Holy Grail. That's the inner sanctum, and that's what you have to guard with your life. Because once they get that, you're gone. You're a goner, mindless. So it's being aware, being aware of the propaganda. Being aware and being a master of your own thoughts is very important, and a good way to do that is to be educated, which brings us back full circle to why we are here. So thank you for that, Jeff.
Pleasure.
I hope that people who've been paying attention have learned a whole lot and maybe got, I know it doesn't help the people who've lost everything and who've got months or years actually ahead of them of hard times, because I've been through it myself here I'm in the Northern Rivers area of New South Wales on the east coast of Australia. We had floods go through and devastate a bunch of towns back in 2022, February. We had 2 floods actually, one in the end of February and then another one a few days later, almost as bad. And it absolutely devastated. The town is still trying to recuperate now. It's probably, I think it's about 80% of the shops, although I debate that. 80% of the shops have opened again, but there's a heck of a lot of still empty shops and things. And, it was hard. Services weren't around for a while. I'm sure everyone's pretty much been through something like that for a little while. It's difficult. You've got to be a little bit prepared and resilient, as much as I hate that word because the WEF seem to have taken it over. Resilient TM. I'm talking about human spirit, the real resilience, the gut, the grit. So, this is what we're doing. This is our part of helping people be more self-sufficient and stronger in their minds and their thinking and not letting those bastards own you. So with that, we shall depart. Wish everyone well. Prayers out for everyone who's been affected by Helene. But it won't be the last, unfortunately. Hopefully you'll all be better prepared in physically and mentally for the next one. So thank you very much for your attention. Thank you, Jeff, for all your hard work. That was very good.
Thank you.
And we will catch you all next time on Whether or Not. Thanks, everyone. Bye-bye.